Hello, everyone out there. We're back again to our math journey. And on this journey, our goal is to make math enjoyable and easy. However, if you haven't subscribed yet, please do me a favor to subscribe to our channel, Tutoring Made Easy, and like this video and share to your friends and family. All right, today we're going to continue from where we left off. We are on the topic sets. Now, one of the concepts we've been able to go through the definition of sets. We said sets was propounded by a German mathematician by name George Cantor in 1874 to 1897. We defined sets as a collection of objects. We also looked at a concept known as elements, and we said every member that belongs to a set is an element of that set. We also looked at the concept universal set. And we said this set is the mother of all sets, or it is the set that contains all other sets, or all other sets can come from. Then we also looked at the concept of subset. We looked at the concept of subset. So basically, we we looked at set. Set is a collection of objects, and then we said elements. Elements. We said it is denoted. They are members of a set, and it is denoted by this symbol. And we also looked at the universal set, the mother of all set, mother of all sets, and it's also denoted by something like this or that. We also looked at a subset, and we said that these are is a set falling under the category of another set, falls under another set, under another set, and we said it's denoted by something like that. We also looked at union, the union set, and we said that joining, when you join two or more sets together, two or more sets together, and it's also denoted by this symbol, like a U shape. Then from there we proceeded and did something on intersection, and we said that in this set, its members are in another set. So same members, the same members of one set are in another set. Or I can say some members. Let me make it to be careful. Let me say some members of one set are in another set. And we said it's denoted like an N, something like that. Like an N. So we're going to continue. Today we're going to look at the concept known as complement. A complement set. Now, complement simply means, complement of a set means that the members of that set are not part of the universal set. They are not part of the universal set. So we're going to look at the concept known as complement. 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 Complement set. So they are not part. They're not part of the universal set. Of the universal set. So let's take an example. Let's imagine for a second that we have the universal set, which is this one. We have it. We have 1 to 10. That is our universal set. 5, 6, 7, 8, 9, 10. And we also have a set A. We have set A. And set A is 1, 3, 5, 7, 8, 9, like this. Now, what do you think is going to be the complement? What's going to be the complement of set A? So it is denoted by this symbol. So a complement is denoted. It is denoted by the symbol that on top. So you can say B complement like that. So the complement of set A are members that are not part, they are not in what? They are in the set A. Sorry, they are in the universal set, but they are not in the set A. They're not in the set A. So I would like to change that definition a little bit. Sorry about that. Complement set, they are members that are in the universal set, but they are not part of that set, right? So let me tweak that a little bit. They are part. They are rather part. They are rather a part. The complement set are members that are part. They are a form part. They are part of the universal set and not that set. They are part of the universal set and not the set in question. So we are looking at the complement of A. So we are saying that the complement of A, they are members that are in the universal set, but they are not in the set A. So if we look at one from the universal set, it's already in set A, so that cannot be a complement. If we take two, two is in the universal set, but it's not in the set A. So two is a complement. The next number in the universal set is three. It is also in set A. The next one is four. It is not in set A. So four also becomes a complement. The next number is five. Five is already in set B, in set A. Six is not. So six becomes a complement. The next number is seven. Seven is already in set A. Eight is also already in set A. Nine is already in set A. And the next one is 10. 10 is not in set A. So 10 becomes a complement. So I would like to take that again. A complement set, it's a set that contains members. A complement set is a set that contains members that are part, those members, they are part of the universal set. So you can see there's a complement set. The members here are part of the universal set. They are in the universal set, but they are not in the set in question. They are not in this set, per se. So if I say we have maybe set, let's say we have set B, and in this set we have something like maybe 1, 2, 6, 7, right? And I want to find set B complement. We are saying that they should be members that are in the universal set, but they are not in this set. So if I take one, one is already in set B, so it's not a complement. The next is two, two is already in set B, it's not a complement. If I take three, three is not, so three becomes a complement. If I take four, four is not, so four becomes a complement. If I take five, which is in the universal set and it's not in set B, it's also a complement. The next one is six. Six is already in set B, so we ignore that. Seven is also already in set B, we ignore that. But 8, 9, and 10, both of them are not in set B. So we can say that 8, 9, and 10 are part of the complement of set B. So you can see that the complement of this set, this set contains members. It contains members that are part of the universal set. You can see 3 is here, 4 is here, 5 is there, 8 is here, 9 is there, and then 10 is there. So the the complement of B are members that are already in the universal set, but they are not part of the set B. They are not in set B. I hope this clarifies the complement of a set. I'd like us to look at a concept known as the disjoint set. The disjoint set. Two sets are said to be disjoint if they contain each set contains members that are different from each other. It means that the sets are disjoint. All right, they are not in agreement. They are not in agreement at all. They're not in agreement. So the next concept we said is disjoint set. A 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 disjoint set. So let's look at. I'm saying that there are members that are not. They are not part of any of this, any other. So let's say you have set A. Let's say you have set A, and it contains the numbers 1, 2, 3, 4, and 5. And you also have, let's say, set B contains 6, 7, 8, 9, and 10. It is evidently clear that the members in set A are not the same members in set B, and the members in set B are also not in set A. So these two sets are disjoint. We can say that set A. We can say that set A is disjoint from set B. Set A is disjoint from set B. So when we do this in on a Venn diagram, this is called a Venn diagram. We are not there yet, but if we do this as a Venn diagram, this is set A, and then this is set B. They are they are they are minding their own their own business. They are not the same. Now let's look at a null set or another concept. But before we do that, whenever two sets are disjoint, it means that their union, when you bring those two sets together, we have something. It becomes what? It becomes what? A null. It becomes zero. It doesn't. There's nothing. It becomes empty. There's nothing in there. All this. All right. Write a zero and cross it through. So we're going to look at a concept, and the concept is known as a null set. A null set, or what we call an empty set. A null set. Now, null set and empty set, they are the same. A null set, this one is denoted by something like this. You write a zero and cross it. But with an empty set, it is also like this. It's empty. Both of them mean the same thing. Now, whenever you and I have a disjoint set, when we have a disjoint set, what it means that there will be a null. It's a null set or empty. So it means that A union B, like we have said, will be empty. It will become an empty set or to become a null set because there's nothing common between the two. If you look at set A and set B, if you want to have set A union B from above these two, we can see that there's nothing common. There's nothing common between them. Did I say? Sorry. Thing I want to talk about is intersection. Intersection. A union B, we can be able to do A union B, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's possible. We can be able to do that. So A union B rather exists. So A union B, rewrite this, please forgive me. Pardon me for the confusion. A union B rather exists. A union B exists. Joining those two sets together that are disjoint, it exists. But however, what doesn't exist is this. A intersection B is rather this. Is that a null or empty? So if we look at A intersection B, there's no commonality. If you look at these two sets here, 1 is not here, 2 is not there, 3 is not in set B, 4 is not in set B, 5 is also not there. There's nothing common, it's empty, all that. So when we are talking about disjoint set, I would like to clarify that, please. Disjoint set, it means that there's nothing common between the two. So what it means is when you want to join those two sets together or to find the union of those two sets, it will exist. You can bring them together. However, if you want to find the intersection of those two sets, it is a null set or an empty set. It doesn't exist. It doesn't exist. So it does not exist. Does not exist. What does not exist? A intersection B doesn't exist whenever we have a disjoint. Whenever we have a disjoint set. All right. I'd like to end here. We'll come again and we'll continue. The next time we meet, we'll be talking about De Morgan's laws. We're talking about De Morgan's laws. All right. I'll come back to you again. Take care. Bye.